Hi class, and welcome back to week 4. We're still in lesson 4.2, and we've been talking endlessly about spirals, and perhaps some of you are getting sick of that, but I want to spend a few minutes just talking about why we keep talking about spirals and why we have the biomimicry design spirals. First of all, I just want to point out that I'm guessing you've seen spirals in nature, because there are spirals all over nature. You may have seen them during your BCI sessions. I'm sure you've seen them throughout your lives, especially as a kid. You can't help but notice them. You can see them here in plants. You can see them in swirls in water and in eddies. You can see them in weather patterns. If you look at whether you're looking at the whole globe, or you're just watching weather on TV, you can see the swirls of huge weather systems. They even go so far as entire galaxies are based on swirls. So you see them all over nature and at every scale. And luckily for us humans, we find these spirals in nature just incredibly compelling. I mean, how can you not find this geometry absolutely visually compelling, and somehow it ignites this visceral feeling too, doesn't it? And you don't just see spirals in one direction. We see what looks like almost perfect geometry in nature sometimes. You have to wonder, gosh, how could you, without any kind of machines or tools or measuring devices, come up with this perfect geometry? And often that perfect geometry you see in nature, this unfolding, this opening, these perfect shapes, are based on the spiral geometry. And it's not just a static geometry. Here's some like a bunch-like grass that we found in a desert in Mexico, and here you can see one of the functions that spirals play in nature. If wind blows straight through this grass, it would just have a one pass through, right? But if the wind blows on this grass or this geometry, it starts to respond by forming the spiral shape. Can you see that? And what that does is, instead of just blowing right through or right over, the wind goes around and around the plant a couple of times, so the plant can get more use out of that wind, whether it's a cooling mechanism or collecting up pollen so it can send it off on its way, or if it's blowing in moisture or fog or rain, and it can distribute much better if it's captured and swirled around inside the plant before it passes on. We've all seen this one for sure, these pine cones in nature, and pine cones are really a favorite of mine. I tend to collect them wherever I go. You can see the geometry here and here. Each one of these is a single spiral that follows that geometry. And then you can see it really clearly in the pine cone, and also things like a sunflower. That spiral pattern also comes off in the other direction. Okay, so you have a set of spirals one direction and a set of spirals in the other. And as you will talk about in a minute, there's a certain ratio that's formed that creates the geometry behind these spirals, and the number of spirals in one direction in ratio to the other direction also is this special geometry that we're talking about. And you can see it in many directions. Here you've got not only spirals going in two directions, but they're these are formed on top of others in this huge big fractal pattern. So you've got spirals both in volume and in growth over time. So clearly there's something really either important, fundamental, or you can't avoid the spiral in nature. And it's not always just spirals upon spirals. Here you get this radial pattern on top of that spiral pattern we were talking about, and you get this spike. So you can have multiple strategies, multiple patterns embedded with or within or on top of that spiral. So we've seen them in the sea and in plants and in the forest and in food, and here we see them in a marine environment at a very teeny tiny scale. So one of the things that you might notice, or you may have noticed already, is that the spiral, you see it in growth patterns a lot. These little tiny babies, in this case a fern frond, is in a spiral shape. When it gets bigger, it's not as clear. But see how the inside is always protected as it's slowly emerging? And it can then allow this other sort of pattern to come out at an appropriate rate when it's ready. So the spiral allows for optimal protection of the young inside so it can function while it's growing. You may have seen this in your garden, these little tendrils that reach out and grab onto things to provide structural support. So this, in this case, it's showing that this can reach out in 360 directions and capture something, whatever it hits in its path. So instead of going straight, and if it misses it slightly, it misses it completely, right? Where this way, by going in circles as it's reaching out, forming this spiral, it will always have the opportunity to find whatever it's looking for. In this case, I'm sure it's structural, but even though it looks like it's looking for water in this picture. And we find it, the pictures I've showed you so far are mostly from plants, but of course we find it in animals too, and even in your own body. Your fingernails would grow like this if you let them grow long enough. Perhaps the quintessential spiral in nature is this nautilus shell, partly because it tends not to be subjected to the variety of disturbances and forces you see in other environments. It ends up growing in this beautiful shape, and it forms this rigid structure, so it's well preserved. One of the neat things it's really clear in the nautilus is that I don't know what it is, but whatever the function is that this shape is providing, whether it's the single curve shape or the shape of this whole chamber, that proportion is reflected in every single one of these chambers, the same geometric proportion. So whatever the shape-based or form-based strategy that's being used by the nautilus is present from the very beginning, when it's very, very young, tiny nautilus, and it keeps going as it grows and grows and grows. So this allows for infinite proportional growth, and that's really important when those proportions are key for functionality. And again, that nautilus is really obvious with the geometry when you look at it here. So the geometry we've been talking about is the Fibonacci sequence, or the Fibonacci spiral, the golden ratio or phi. If you've had classes or done investigations into classic art or architecture, that comes up all the time, doesn't it? And that ratio is what you see here. It's about 1.16 to 1. Okay, so it forms a rectangle that is 1.6 times the length that it is the width. And if you can see that when you have this rectangle, you end up forming this perfect square, which in this case is 1 to 1. Of course, all squares are 1 to 1. So here's the 1 by 1. This length is 1.16. And if you form this square, what you end up with is another rectangle with the exact same proportions. That's not what I'm showing in this particular one. Here we go. So you have, again, 1 to 1.168. And if you form that square, you get another rectangle of that same proportion, and et cetera, et cetera. So if you keep going forming squares, the resulting rectangle has that same proportion. I know I'm going inward, but it's easier to show that way when actually it grows outward. With each of these squares, if you form a perfect quarter circle, and quarter circle, and quarter circle, what you end up with is that spiral that you see all over nature and in classic art and architecture. So some of the functions about this geometry that we've mentioned already: it allows for infinite proportional growth. So again, shape-based strategies can function and be maintained every moment while that organism is living and growing. It can't afford to have like one design done, tick done, put it in a box, not to be altered anymore. It keeps functioning as it's dynamically growing. Also, as we looked at earlier with that desert plant, it allows or induces natural swirls of water and air, because water and air also move according to this geometry, as we've seen. There are no sharp edges. Of course, the squares that form this geometry don't exist. We just have this spiral. So there aren't any sharp edges or to get for structural forces to gather and cause defects. It's not prone to cracking at corners, for example. It doesn't scratch anything. And like the pine cone, when it falls, it's allowed to roll in certain directions. And these are just a few of the many reasons why we have spirals in nature. And we talked before about the linear design process and then really making a cycle out of it, or a circle, and how really it's capturing the idea, but in practice what happens is that you really commit to doing one step, then another, and by the time you get to the end, it's a bit of a daunting task, and you may not have the luxury in your work to actually go through the whole thing again. And we talked about some people capturing the idea of the spiral somewhat, sometimes though it's going inward, which is losing one of the beauties that we want to capture. So the key in our design spirals, or one of them, as is true in nature, is that the spiral goes outward. Okay, so instead of honing in on a solution, you've got a cyclic process, but it's going out, and it gets bigger and slower as you go. And in the Challenge to Biology design spiral, which we'll be using for the remainder of the course, it looks like this. Again, you see the spiral going outward. And I wanted to let you know where this came from. There's a guy named Carl Hastrich. He's an industrial designer. He's Australian, but he's living in Canada. He's working with the Ontario College of Art and Design. He was working with Janine Benyus and her colleagues way back when, in 2004, 2005. And he realized that in order to capture the power of biomimetic design, the standard design process wouldn't work. There had to be something more to it. And what he came up with was the spiral process. He took a linear process and rolled it up, and then realized that you needed to have this wild exploration at the beginning and learn and learn and learn, and go around and around many, many times before you really dove into a more serious, slower, more thorough design process. So like nature, you'd have infinite opportunity for exploring, adapting, and evolving a design. So just learning and practicing the spiral approach will make you a better designer, even if you don't particularly get your inspiration from nature. So one of the other beauties of this spiral is that even though when we talk about a particular design spiral, we say, okay, you start here and then you go on to the next step, you can actually start here or there. And you may have noticed this now by comparing the biology to design spiral with the challenge to biology spiral, that they're simply starting in a different, same thing, starting in a different place. Of course, the objectives are also different. But you can start in different places. And when you did, when you evaluated a product against life's principles, you actually started at the, quote, end of the design spiral, and then you did this with it, which, as hopefully you noticed, is not only can you take the time to evaluate something against nature's principles, it is an opportunity to drive radical design. So you can take an existing design and start here, and again, get fantastic results out of the design spiral. And the neat thing is, as I already mentioned probably a few times already, is that you get to start small. So this idea of just do it, okay? Allow yourself to give it a go, let go, see how it works, get radical, get wild, try some really different ideas, learn a lot. It's really about learning, and then reflecting on what you learn, and then using what you learn to move ahead. Okay, so instead of committing to one big, long step and really thorough doing each step, you do you go through all of them very quickly at the beginning, learning, and then before you kind of go, okay, now I'm getting where I'm going, now I'm going to dive deeper and spend a little more time on each lap around the spiral. And the other key is taking lots of laps. So in addition to the quick ones at the beginning, each time you get to the evaluate stage, in the case of the challenge to biology spiral, you pause and reflect. And that's why reflecting is really important. I would do this, you could do that in your BCI sessions before you move on and rethink, what is it I'm really trying to do and how can I find that in nature? So taking many, many laps allows for continual innovation, continual learning, continual responsivity, and adaptability. So the design process itself is biomimetic and resilient. And the other neat thing is it works for anything. Now you're all designers. Well, you may not all be designers, but you find yourself doing design, at least in this class. But it works for really for anything. If you're working on a project or a paper and you find yourself stuck, well, pause and say, you go to evaluate and say, well, what is it that I want my sentence to do? And so you really go through the identify stage with whatever it is that you're working on, and then when you go to abstract, discover, etc., you'll find you'll bust out of that rut you're in. You'll be unstuck, and you'll discover radical new ideas. And again, you may not even use those ideas, but it gets you driving around and unstuck and working towards a more positive outcome. And this is another example. You can use it for creating a party. Who should I invite? And you ask yourself, what is it you want that party to do? And again, you drive around with that, the spirals with that design challenge in mind. Okay, enough on spirals. Apologies if it's too much, but again, you'll find, or at least I've found, that the spiral is an incredibly powerful design process, and I encourage you to keep looking for that geometry in nature. Okay, so we'll see you in the next video.